So I was able to build a radio telescope for free. Um, I have this idea that on August 15th, 2015, the SETI signal from extraterrestrials, if that's what it was, will repeat itself. And so I needed to build a radio telescope in order to measure it on that day if it repeats. And I was able to build a radio telescope for free. My brother was throwing away this old satellite dish, and so I was able to use it. The radio waves come in, they hit the dish, they're focused onto the receiver, and that's converted to an electrical signal that you plug into a meter, and you just have to measure it, have a power source and so actually the only investment I had to make was in a meter, which was $1.75, and this is the signal meter. This is the signal meter, and so the next step is to align your telescope. If you have to have you have to lean the vertical axis. I have a tripod. It's mounted on a tripod that my brother's kids found, and it's on the tripod, but you want the vertical axis to be tilted so it's pointing at the North Star, because the stars rise and set around the North Star. So if you get a off-axis alignment, you can track you only have to track the stars as they rise and set in one direction. I looked it up on the computer. I'm near Los Angeles. That's a latitude of 34 degrees above the equator. So the North Star is then 34 degrees above the horizon. So the telescope has to be inclined 34 degrees above the horizon. And I have this telescope tilted at the maximum angle above the horizon, and that happens to be exactly 34 degrees. So obviously they manufactured this telescope for my latitude. You can actually measure it with a sextant. I made one out of a protractor. I just drill a hole in the crossbeam, and you bend a piece of wire and hang it from there, and it points straight down, and the angle rotates through it. So let's measure that. I'll measure that. Let's see here. Set the camera. Okay, so as you can see, here's the telescope, and I will place the sextant on the axis, the vertical axis. As you can see, it's inclined 34 degrees above the horizon, which is just right. You want to make sure your telescope is level, so you need a bullseye level, and that's what it looks like. And so you just place that on there, and make sure it's level. Then then the thing we need to do is we've got it pointing up to the North Star, and now we have to move it horizontally so that it points due north, and you need a compass to do that. And just place the compass on there, and it's actually okay. Okay, it's now pointing at magnetic north, not true north. You want it pointing at true north. So you have to know the magnetic declination for your latitude. And I'm near Ontario, and you can look it up on the computer. Google Maps shows that the magnetic declination for Ontario is about 12 degrees east. And that means that magnetic north is 12 degrees east of true north. So you measure with your compass 12 degrees east of true north. So, I mean west of true north, because magnetic field is 12 degrees east of true north, so you have to rotate your telescope 12 degrees west. And there, it's about 12 degrees west of true north. So now, as stars rise and set, you only have to track along one direction. Here's the North Pole, and the stars rise and set around the Earth's axis that points at the North Pole. This is inclined at the same angle. So you can see the stars rise over here. So if you're looking at a constellation over there, it rises, and in the course of the night, it sets in the west. So that way you only have to track along one direction. So I'll hook up the signal meter to the power source. I already had this as a 12-volt adapter. I just soldered a BFC connector onto that, and plug in that power source. Okay. Okay, so now you want to increase the gain until you get the noise level of the sky. That is all the background radio waves, like from satellites and the moon. And increase the gain until it makes a sound. Okay. And I'll turn it just below the sound, so it reads +4 when it makes a sound. And I'll turn it just below that, so if I get a signal from extraterrestrials, and my theory says that they should be in Sagittarius, and that's where it's pointing now. If I get a signal from them that's above the noise level, the sound will go on. And so the idea is that they will send a signal and then turn it off, and then send another signal and turn it off, and send another signal and turn it off, and then pause. And so they'll speak a mathematical language. That's the common language throughout the universe. So, for instance, they might, to let us know they're intelligent, they might send a mathematical message, which would be maybe 3 beeps, a pause, then 2 beeps, because 3 and 2 are Fibonacci numbers, and the ratio of 3 to 2 is an approximation to the golden ratio. So you would get a signal as 3 and then 2.